Hi everyone, hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Pre-Level. So without wasting any time, we'll quickly get us started with the very first part of DBMS where we take a quick introduction about the entire database management systems. But before actually moving on to anything, we'll first talk about what a data is. Okay, so please follow the slides with me. They are, I would say, a holistic slides that cover almost everything that is required for databases. So, how do we define data? Data is nothing but facts and statistics that are either stored or they are free flowing over the network, right? You have a lot of data, you are exchanging data over the internet, you're getting some data, you're storing some data over the internet, right? So, data is nothing but these are some facts or statistics that are freely flowing over the internet or they are stored over the internet as well, and generally it's raw and unprocessed, right? You just have a file, you just upload your file on the internet, it's unprocessed, nobody's processing it, nobody's doing some analysis on top of it, and the file is completely raw. For example, when you visit any website, they might store your IP address, that is data, right? And in return, you might add a cookie in your browser, making or marking that you visited the website, that is data. Your name, it's data, your age, it's data, right? So whenever you visit some website, right, there is usually a pop-up that comes up that do you allow cookies on this website as well, right? So that is how they store your data, that is your IP address and everything that you have. Okay, now data and information, there's like a difference between them. Data becomes information when it is processed, okay, turning it into something useful, like based on the cookie saved on the user's browser. If a website can analyze generally men of age 20 to 25 visit us more, that is information, okay, derived from the data collected. Let's come over here. When we talk about data and when we talk about information, both of them are not the same. Okay, data is processed information, okay, or unprocessed information, sorry, and information is processed facts and statistics, or rather let's define it in a better way. Data is unprocessed facts and statistics, although it can be more than that as well. Information is processed facts and statistics, okay, the information that has been processed. So if a browser or a website is storing my IP address, right, then just storing that particular fact or particular information, right, anything, that's a data, right? But when they try to use that information, when they try to use the IP addresses and store simultaneously my name, my age, my address, or anything, right, and then they are using it to draw the analysis that certain number of people, right, or certain age group of people are coming to their website more, that is information now, right? When you are processing some information, when you are drawing some analysis based on the information or the data, that's when it actually becomes processed, and that's when it actually called information. Okay, so that's one of the key differences when we talk about data and when we talk about information. So that is why it says data becomes information when it is processed, and then it becomes something and it turns into something useful, right, where the website can actually use that data now instead of just keeping it raw, keeping it unprocessed. Okay, so now that we understand what data is, we can also talk about what a database is. Remember, we are breaking down the terms very easily. Okay, we talked about what a data is. Now let's talk about what a database is. Now, a database is a collection of related data organized in a way that data can be easily accessed, managed, and updated. Okay, and database can be software based or hardware based with one sole purpose: storing data. Okay, now a organized way of storing all your data, related data, is known as a database. Think of it as a school. Okay, you have a big school, right? You're running a school, and in that school you have a lot of students. Now the information of all the students is something that you need to store. Now, what all information you need to store about the students is very similar, right? For every student, you'll store their name, you'll store their age, you'll store their current standard, their address, their parent details, right? And some more information about that as well. So this is similar information that you will store for different students, right? So a collection of related data is here students, right? A lot of students with similar kind of information we are storing. A collection of all of that organized in such a way that it's very easy to access. That means to see the information about different students, to manage the information. Let's say some students left the school, some more students got added to the school, right? So to update that information and to manage that information. As in, let's say I just want to see how many students are in 5th class, right? So to perform all these operations in an optimized way, right, a database is something that comes into our picture. So a database stores all of your information in a logical way, in an organized way, such that all these operations becomes very easy to do. Now, the next point it says with that is that database can be software based or it can be hardware based, okay, with the sole purpose that it has to store data. The main purpose is to store data. Now, whether that information or the way you are storing it could be in terms of a software, that a software is storing all of the information, or it could be a hardware that you're using external hardwares to store all your information. But anything that stores related data is a database, okay? Anything that stores a collection of related data in a very organized way will be called a database. Now, a database can be present as a software in your computer where it is storing all the information, or you could be using external hardwares as well. Now, during early computer days, data was collected and stored on tapes, which were mostly write only, which means once data is stored in it, it can never be read again. So earlier, do you remember we used to use CD drives, DVDs, which have kind of become obsolete these days. Even computers do not provide the facility to, read the CDs and DVDs and anything like that, right? Pen drive is still a little bit used these days, but still, I think everything with the intervention of cloud has become so obsolete that you don't have to use any external hardwares. Everything you have can be uploaded on the cloud, on the internet, and it stores forever, right? You have no worry of losing that information. But in the early days, everything was stored in tapes, right? Big magnetic tapes. I'm not sure how many of you have seen it, but there used to be big magnetic tapes where we used to store all our information, and it used to be write only. That you have your information, you store it, right? It's going to be there forever, but it's only write only, right? You cannot update it. Once you've written some information, it stays there forever. Okay, so during early computer days, data was mostly stored in tapes. Okay, it was used to write. You can store anything you want, but you usually could not read it again and again. Okay, and they were very slow and they were very bulky. One magnetic tape usually used to be this wide. Okay, so it used to take a lot of space. It used to fill entire rooms just for storing very small amount of data. Plus, it was very slow to write information in it as well. So it was slow and it was bulky. Okay, and soon computer scientists realized that they needed a better solution for the problem. So when you have small amount of information, even tapes are fine. You can use tapes, you can store information using tapes, and it takes some space, but that space is not very substantial. But the problem started to happen when the amount of data increased. And you can see in the current time, data is such a big, powerful weapon these days. Companies are, analyzing and, working on so much, they're sitting on top of so much data that it's very important to analyze it and draw good and important conclusions based on that. So that's when the problem started to happen. When computer scientists realized that processing data has so much worth, right? It has so much advantages, right? But the data was so big, right? And the process of storing data in tapes was so slow, they realized they need a better solution. They need to come up with something which is faster, right? Which is less bulkier, it takes up less space. Okay. And with that, what happened was Larry Ellison, the co-founder of Oracle, was amongst the very few people who realized that the need for a software-based management system was required. Okay, so earlier everything was hardware based. All the databases were hardware based. You were storing tapes, you were using DVDs for storing all your information. But soon they realized that they need something software based, which can come inside in a computer, right? Which can be stored inside your systems, which runs through softwares, and it stores all your information. And that's when the need comes in for a better solution. With that, I would say the introduction of DBMS, database management systems, basically kicks in. Now, a DBMS is a software that allows creation, definition, and manipulation of databases, allowing users to store, process, and analyze data very easily. Okay, so a database management system is basically like a software, okay, which you can download and which you can run on your computers, and that allows you to create databases, right? That allows you to define databases, right? By definition, I mean that let's say you have a school again and you want to store information. So you are defining the properties of the databases as well, as in what all information will you store for a student, right? How much information will you store, right? So that's definition of databases. Then we came to manipulation of databases. Manipulation is, let's say again, I want to manipulate the data. I want to remove some students. I want to add some more students. So I am manipulating or making changes, updating the databases according to my use case. And that allowed user to store the information, process the information, draw some analysis. So there are different queries that you can write on the databases to draw some analysis on the databases and the information that you have, right, over this. So DBMS was like one-stop solution for all these operations that you wanted to do. And that's pretty much the things that we wanted to do with the database as well. So DBMS provides us with an interface or a tool to perform various operations like creating database, storing data in it, updating the data, creating tables in the database, and a lot more. So if you're storing the data of all the information that you have in terms of tables, right? DBMS as a software allowed you the capability to create tables inside a database. Let's say you want to create a table of students for all the students that you have in your school. Let's say you want to create a table of teachers for all the teachers that you have in your school, right? Let's say you want to create an information about what all subjects you teach in your school. So you have a separate table for that, right? So DBMS not only allowed you to do these capabilities, it allowed a very easy and a user-friendly interface, right? Interface is what you see, the UI, which helps you to do all these tasks very easily, right? You just have to perform simple operations and you could do a lot of operations on these softwares. And what is this software called? Database management systems. Now, a DBMS also provides not just these capabilities, but it also provides protection and security to the databases, right? Now, you have some information, right? Let's say your information is very, very crucial. You're storing some, let's say, information about all the students you have in your school. You're storing their phone number, you're storing their addresses, right? And you cannot afford to lose this information, because if it comes in the hands of a wrong person, right, it can do great problems to you. So what you want is, you want a software which not just allows you to perform operations on the data, but it actually keeps your databases really secure, right? So database management systems as softwares do provide these capabilities for protection and security to the databases as well. When you're using hardware based, if someone steals your hardware, right, if someone steals your tapes or your disk, it's very difficult to make sure that you get that information back, right? And it's not that difficult to steal that information as well. But when you have everything in a software, it's very crucial, with the evidence of hackers these days and the people who try to steal your information. It's equally important that if all of your information is in one place, there are certain measures and there are certain ways put into place using which you can protect and secure your databases. And it also maintains data consistency in case of multiple users. Data consistency as a topic will come in great lengths, in great details later, right, where we talk about what exactly happens in data consistency. But just to give you a quick idea, right, data consistency basically means, and it's very crucial specifically for banking purposes, right? Let's say I'm storing some information in my database. Now database management systems are nothing but softwares, right? What if I'm trying to someone deposited some money in my account, I'm trying to make that entry into the database, and immediately the light goes off, correct? Now after that, what happens is what the database management systems have to take care of, right? We need to maintain data consistency. If someone deposited 1,000 rupees, we want to make sure that the database management systems make sure that they are consistent, and in the end, even after failure of a transaction or a information that I would store, it has certain measures put into place so that the information can be used. And what if I am trying to store some information of students in the database, and similarly, like I'm trying to add some more information, and at the same time someone is trying to deceive and get all the students in the class as well. So we want to make sure that the data is consistent. If I am storing more information in the database, the other person who is accessing should also see the newly added students. So it's about data consistency, data accuracy. The data should be accurate, right? There should be no problems with the data. And the responsibility for database management systems is to assure that everything is correct. Now, when we realize that something like a database management systems is there, some popular database management systems that we use these days is first MySQL, right? We also use Oracle. Like I told you in the start, like Larry Ellison realized the need for, I would say, something called a software which can store our information. So they actually came up with Oracle, which is a very popular used database management these days. We have MySQL as well. We have SQL Server. We have IBM DB2, right? We have Postgres SQL, and we also have Amazon SimpleDB, which is cloud based. So that software is like storing all your information in a cloud. So these are all the popular ones, right? Some are used very frequently at user level, like people like students who are studying database management systems. They usually either use MySQL or Oracle, right? Big organizations, big enterprise firms also use MySQL and Oracle, but along with that, sometimes they also use SQL Server and Amazon SimpleDB based on their use case. Each of these database management systems provide their own advantages and they have their own pros and cons. So based on your use case, we companies and individuals take the call which one to use for. Now, we will talk about database management systems characteristics. So what all did we cover so far? We talked about what a data is. We talked about what a database management system is, right? And we talked about database as well. So we started with data, we talked about databases, and then we talked about database management systems. So now we'll talk about a few characteristics, right, which you need to keep in mind when you study this topic. So let's go over all of them one by one. The first is that the data is stored into tables, right? Data is not just directly just thrown in the database and the software has to take care of it. Everything is done in a tabular format in database management systems. Let me show you. So if you have some information, let's say I told you, right? Let's say you have to use the database management system software to store a school's information, right? So what you will do is you will create a table, let's say one for students inside the database, right? And here you will store the roll number of the student, here you will store the name of the student, here you will store, let's say, the age of the student, right? Here you will store the phone number of the student, and so on, and all the students data will come over here. Okay, similarly, let's say I am storing all the information of the teachers. Similar thing will happen here as well. Everything has to go in tables and stored in rows and columns. Let's say I am again having a unique ID for each teacher, right? I am storing the name of that teacher, I am storing the age of that teacher, the phone number, maybe the class that the teacher teaches, and so on, right? So everything is stored in a tabular format. Okay, it's not just directly stored, it's not like data and just stored there in a raw manner. It's everything is organized into tables which are created inside the database. Now, databases management systems also allow you to have relationship between tables, which make the data more meaningful and connected. Okay, you can easily understand what type of data is stored by looking at all the tables created in the database. Okay, now don't you think the moment I say that I am storing students, right? Student is a table, teacher is a table. Let's say I also have a table for subject, right? So the data is organized into the tables in such a meaningful way that it's quite easy to tell by that what kind of information is stored in the database. So with this, it's very easy to relate the fact that the information stored over here is for a school, right? A school's information and a school's database is present over here. And the other point was that whatever information you stored in database, right, database management systems allow you to have meaningful relationships. For example, let's say here this teacher basically teaches a few subjects, okay, and the subject table is like this: subject ID and the subject name. Okay, so let's say if I do subject ID is 2, 3, 4, 5, so on, and let's say this is English and this is Hindi and so on, and let's say there is a teacher with a unique ID, let's say 356, her name is Anu, her age is 35, her phone number is this, she teaches the 3rd class and she teaches the subject 2. Okay, so now this is like a relationship between the tables, correct? The subject that she teaches has a ID 2, and if I go over here on the subject table, if the subject ID is 2, the subject is English. So with this, I can analyze that the teacher teaches the subject English. Okay, so there is like a way we can derive meaningful relationship between the data, right? Let's say if I do 2, 3, if I'm storing 2 information, that means the teacher teaches English as well as the teacher teaches Hindi as well. Okay, so that's how we try to use the information, and that's how we try to draw meaningful relationships with the information that we have. So that is the first point, that everything is organized into tables. The second thing is reduced redundancy. In the modern world, hard drives are very cheap, right? But because now their usage has gone so low that they kind of become cheaper now. But earlier, when hard drives were too expensive, unnecessary repetition of data in the database was a very big problem. So if you're storing information in the earlier times also in a database, right, the problem was that there was so much data, right, and there was it was very common to have repetitive data in the database that created a very big problem. Already you have less space, already the way you are storing the information is very bulky and it's very slow, and on top of that, if you will start putting unnecessary and repetitive information, right, it will become a very difficult task, okay, to store all of it, and it will become a big problem. But database management systems follows the concept of normalization, which is a very, very important concept, right? Which we will cover in detail as well in the next few sessions, where we talk about a way in which normalization helps to reduce the redundancy in data and it keeps it at the bare minimum. So whatever information is not required, whatever information is not, like kind of repetitive and we can live without that information being so much repetitive as well, right? Normalization makes sure that that kind of information is removed and the repetition is basically kept to the bare minimum. Okay, so reduced redundancy is that you just keep redundant data as much as is required. Apart from that, you do not store any kind of repetitive data. And database management systems do provide that capability over here. The other thing is data consistency, right? Like I said, that when we are dealing with live data, when someone is storing, depositing money in the bank, at the same time someone is withdrawing data from, withdrawing money from the bank as well, right? That is, the data is being continuously updated and added, right? Think of a bank. They have like thousands of people who have their accounts, right? All of them are storing some money, all of them are removing money, right? They're withdrawing, they're depositing, so much is happening, right? And in that scenarios, and so much is happening in such a fast rate, it's very important that the consistency of data is maintained. And on live data, the data which is continuously changing, it's become very difficult, right? And it becomes very important to deal with the consistency. Let me give you another example. When you're watching, let's say a video on YouTube, you can see that the views on the videos keeps on updating, right? So it's happening on live data. The data is getting updated in lifetime. As in when you watch the video, right, the databases which are being used by YouTube, they have to consistently update their own database based on what the views the video has and constantly update you as well, because you are looking at the views, correct? So you should see the updated views, right? So data consistency is a very big issue, right? But database management systems handles it all by itself. The next point being support multiple user and concurrent access. Okay, now database management systems allow multiple users to work on it at the same time. Let's say you are in a bank. Again, there are many employees in the bank. You just don't want the manager of the bank to access the data, correct? Because otherwise it will become very difficult to perform all the tasks by a single person. You have a certain set of employees below you and you want to give all of them the access to work on the data. So database management systems allow multiple users to work on the data. All of them can update the data. All of them can insert information in the data, and all of them can delete the data at the same time, right? And still manage the data consistency. Let's say there is one person, right, who's working on the data where he's trying to update some money that a person deposited, and at the very same time the other person is querying and checking the information and the balance of that person in the database. So you have to maintain consistency. You have to make sure that both of them gets the same answer, right? So concurrent access and support multiple user functionalities is also provided by database management systems. Along with that, we have the query language, right? So you have to, let's say, see how many people in your bank have an account balance for more than, let's say, 2 lakh rupees, right? So you want some way to tell your database management systems what you want to do, right? I want to see what all people have their balance in the account greater than 2 lakh rupees, right? So now it's not we cannot convey this information to our softwares in an English way, right? Because they don't understand it. So we want some common language, right, using which I can write my query, right? I can ask my question and the software understands and answer it, right? So the way we communicate our information to the database management systems, the way we query and ask questions to these softwares is through a very purpose language that we require, which is known as a query language. That query language will help you to fetch information. That query language will add information in your database management systems. It will delete information. It will update the information in a database. But you need some way, some language to communicate this to the database management systems. So All of these DBMS softwares do provide these query languages, and they understand these query languages using which you can perform the task. Okay? And with it, the other one, which I think we talked about earlier as well, is about security. The database management systems take care of the security of data. Think of it like a bank data, which is storing so much information about you. The security of the data is the utmost priority of the banks, right? You want to protect the data from any unauthorized access, and DBMS softwares do take care of that. In a typical database management systems, we can create user accounts with different access permissions, right? So let's say if it's a normal employee, if it's a clerk, they can just view the information, they cannot do anything on it. But let's say if I have a manager, the manager can do changes in the database in terms of, if they want to update some, let's say the Aadhaar of a particular employee, and let's say they want to update, let's say the bank information for a particular, let's say customer, they want to open a new account for a particular customer. So all these kind of permissions or access permissions can be given to different people in the database. So we can define user permissions. Someone can have a lot of access to do something on a database, but the other person may or may not have all the access permissions, right? So using these functionalities, we try to secure our data by restricting the user access, right? As a customer, I can view all my account details, but I cannot view some other person's account details, okay? If it's a bank employee, they can view everyone's account details, but they cannot do any changes on those details, okay? And they cannot add an account, they cannot delete an account. But if it's a manager, then he or she has the capability to view everyone's account details. They have the capability to create a new account. They have the capability to delete a new account. So based on user access, by restricting the user access, we secure our data. We only give the relevant access to the data to the people who are actually required to do something on it. Okay? And the last point over here is that database management systems support transactions. Okay, it allows you to better handle and manage data integrity in real world applications where multi-threading is extensively used, right? Multi-threading as a concept, I think it will come up in operating systems when you will study, right? You want to maintain data integrity, right? You want to do data correctness. Like I was saying again and again in the previous examples, I deposit some money in the account, at the same time I'm withdrawing as well, right? That if I'm depositing something, my balance should increase. If I'm withdrawing something, the balance should decrease. So all of it is like a transaction, right? I deposited something, I withdrew something. So this is like one complete transaction that I am doing. So database management systems are well equipped to support multiple transactions to handle data and maintain the integrity of the data in the real world applications where multi-threading is very common. Multi-threading in the sense is like parallelly we are doing a lot of jobs, right? So in those situations where multi-threading as a concept has become so extensively popular, database management systems do support the functionalities required for that. Okay, so with this we conclude our very basic, extremely basic introduction about database management systems. Just to conclude what all we talked about today, we started our discussion with the very basic topic about what a data is, right? What exactly is a data? How do we define data? Then we talked about what an information is, right? And how a data is different from an information. Data is nothing but unprocessed fact, unprocessed statistics, and when we process all that data, it gets converted into an information. So once we understood what a data was, we started to talk about what a database is. It is just a logical organization of all your data. Okay, you can store the data in the hardware, you can store the data in the software. Moving on to that, we talked about what a database management system is. So it's a software-based way of organizing all your data, because the hardware-based way of storing databases was very bulky and was very slow. So we introduced database management systems, which is a software which allows you to create database, update database, delete database information in the database, define a database, and a lot more information on top of that. So a lot of capabilities provided by database management systems. And then we talked about what are the common and the important characteristics that you have to understand about database management systems, right? We talked about a lot of facts that everything is going to be stored in tables. We do not want to keep redundant data as it is very expensive. We want to make sure that the data is consistent. We want to support multiple users and we want to allow them concurrent access to the data. We want to make sure that we can communicate our queries, right, and our objectives with the databases using a query language, which we will talk about in later. Then we talked about how do we maintain, and we want to make sure that the data is secure, and we want to provide the transactional functionality. This concludes our very first video on database management systems. In the next videos, we'll talk about what are the advantages of database management systems, right? What are the disadvantages? What are the key points that we need to take in mind while creating databases? And we'll try to get a little hands-on in the future videos as well. Till then, I would recommend go through the slides once again, make sure you understand each and every point, each and every word in the slides in it, and you actually are able to grasp the very basic topics. Till then, thank you so much. Thank you so much for taking a look at this video. I hope it was really helpful, and I will definitely meet you in the next videos. Thank you. Bye.